Good morning, dear friends. Today we are going to see a new chapter, Effects of Electric Current. In the previous class, I have told you to revise your 9th class textbook, which you have studied about electricity. When we come into the topic, Effects of Electric Current, we know that electricity having various effects. What are the various effects? Consider the electrical equipments in your house: electric bulb, electric fan, television, electric heater. Okay, all these are different electrical equipments which is there in your house. All this will work with the input of electrical energy. So when we giving electrical energy to a bulb, LED bulb, what output we are getting? We are getting light energy plus some amount of heat energy. When we using that in electric fan, we are giving electrical energy and the output we are receiving is mechanical energy. So everywhere we can see some type of conversion of electrical energy to another way. Okay, so same way we are going to study two conversion or two effects of electric current in this chapter. One is heating effect and another one is magnetic effect. What do you mean by heating effect? When we giving electrical energy, the output which we are receiving will be is of heat energy, that we will call as heating effect. Okay. So first of all, we need to know what is electric current. We know the definition of electric current. The flow of electrons through a conductor is known as electric current. The flow of what? The flow of electrons through a conductor is known as electric current. Conductor. What is conductor then? Conductor is a substance which allows the passage of electric current. Okay? Any substance which allowing the passage of electric current, we will call that substance as conductor. What are some examples? All the metal, for example, iron, silver, copper, aluminium, all these are conductors. Okay? And again, there are some substances which allow the current partially. What do you mean by partially? Sometimes only it will allow the passage of current. Okay? In certain conditions. It can be some temperature. Okay? According to some condition, if it is allowing the passage of electric current, we will call that substance as semiconductor. Okay? According to certain condition, if it allows the passage of electric current, that is semiconductor. Okay? Now coming to the third substance, it does not allow the passage of current. Okay? That substance we will call as insulator. So according to electricity, passaging substances are classified as three. First one is conductor, semiconductor, and third one is insulator. Okay. Semiconductor example is germanium, silicon are good examples of semiconductor. Okay, now coming to the next topic. So as I asked you for revising the electric current, I think you have gone through the different parameters of electric current. What are the different parameters of electric current? Voltage, resistance, power. These are different parameters of electric current. Again are there. Okay. Mainly we are going to see these three things. Just a revising. What is voltage? This has another name, potential difference. Okay. Consider a electric cell. Take a battery, AA battery, you take it. We know it has two terminals. Okay. This type of battery. Here we will call this one as positive terminal and this one is negative terminal. Okay. Now take an LED bulb. Consider this is an LED bulb. In one leg we connected one wire, another leg another wire. If we connecting both the wire to the positive edge, will the battery will glow? The battery will not glow. So for glowing the battery, what we need to do? One end should be connected to positive and another edge should be connected to the negative. Why is this so? Because for flowing current, what is required? A potential difference is required. Okay, so potential difference can be defined this way. The amount of work done for moving a positive charge from one terminal to another is known as potential difference, otherwise voltage. Okay, now coming to the next parameter, resistance. What do you mean by resistance? Resistance, when current is passing through a substance, okay, it will oppose the flow of current. This opposition tendency or property of the substance, we will call that one as resistance. For example, now I am giving electric current on a wooden table. Will it pass the electric current? No, it won't, because it is an insulator. It has a property to oppose the flow of electric current. Okay, so that is the term resistance, the property of opposing the electric current. Now, what is the principle of heating effect? Okay, when electricity is passing through a substance, it will oppose the flow of current. Okay, because of the property of resistance. When current is not flowing or partially flowing through that substance, okay, heat will generate. The amount of heat will increase. Okay, it will generate heat. When current is flowing through a substance, it will oppose the flow of current or it will partially allow the flow of current. This will generate heat. That is the principle of heating effect. Now, can you tell me some examples of heating effect of electric current equipment, such as water boiler, electric cooker, electric bulb, okay, electric heater? All these are some good examples of heating effect of electric current. Mainly, we are going to study two substance or two equipment which is making use of the heating effect of electric current. First one is incandescent bulb. We know the filament bulb which was there in our home. Now we are not using this one. Okay, now we are using LED bulb. Okay, so previously we were using incandescent bulb, which consists of a tungsten filament. Okay, so first we will study how that works. Okay, later we will go for electric iron. So now how an electric bulb works and what are the main parts of electric bulb. So an electric bulb consists of a tungsten filament. Okay, when electricity passes through this tungsten filament gets heated and it will emit light. It glows. This is the working principle of incandescent bulb. Now coming to the now while making this incandescent bulb, first we need to evacuate the gases which was already inside this glass tube. Outer glass you can see. So that inside air is there, we need to evacuate the air. Okay, why we are evacuating the air? For stopping or for preventing from oxidation, okay, or corrosion, we need to remove the air which was inside the electric bulb. Again, which gas we will fill in this one? We need to fill noble gases such as argon, nitrogen gases. We need to fill into the electric bulb, which will help not to make corrosion and which will elongate the life of tungsten filament. This much only about the incandescent bulb. Mainly you have to remember what is the filament. Filament is made up of tungsten. Okay, you need to remember the melting point of tungsten, which is about 3300 to 3450. Okay, it's not in a correct range. 3330 to 3450 degree Celsius. In this range, it is the melting point of tungsten filament. When it reaches this temperature, okay, it gets heated and it will melt. Now, next one is electric iron. Iron box, everyone is familiar with the iron box. Okay, iron box consists of a heavy metal at the bottom part. Okay, again one mica sheet will be there, one coil is there, that is nichrome coil. Above the nichrome coil, again one mica sheet is there, a covering, you can see one handle and a wire. This is the structure of an electric iron. Okay, so it consists of two mica sheets, one heavy metal and one nichrome coil. Nichrome coil is placed in between this mica sheet. Okay, now remember these are the main parts. Now, why we are using this mica sheet? So, mica sheet is a good conductor of heat and bad conductor of electricity. Thus, when electric current is passing through this mica sheet, below one mica sheet gets heated because of the nichrome coil. Nichrome coil will get heat and it will pass that heat to the below mica sheet. Okay, that mica sheet will help us to iron our clothes. Okay, but it will not pass electricity, so we will not get any electric shock also. That's why we are using a mica sheet in the electric iron. Now, nichrome coil is an alloy which is made up of nickel, chromium, manganese and iron. These are the metals in the alloy of nichrome. Remember, nichrome is made up of nickel, chromium, manganese and iron. So, I hope you understood why we are using mica sheet. Okay, it has two properties. It is good conductor of heat and bad conductor of electricity. Now, what are the factors depending on heating effect of electric current? Now, consider electric bulb, electric iron, electric water heater. Everywhere we are supplying the same amount of heat, right? So, but is it giving the same amount of heat to us? No. Electric bulb heat and electric water heater heat is different. Both are a huge amount of variation is there, right? So, on which factor this heat is dependent? Okay, that's the important topic. Next we are going to see. In 9th class we already studied Joule Flow. Hope you remember. What is Joule Flow? The quantity of heat generated in a conductor of resistance when current I flows through it for a time t is directly proportional to the square of the current and the resistance of the conductor, the time for which the current flows. Okay, that is, according to Joule flow, we can write it is depending on current, the square of the current, the resistance of the substance, and for how much time this current is flowing through the substance. So, equation is H equal to I square RT. So, there is a derivation, okay. I will tell you later. It has three equations. All the three equations, how to derive, I will tell you later in the next classes. Now, just to remember, the main equation of Joule flow, H equal to I square R. So for today we are winding up. While we coming to the next class, please revise all these topics and come next class in I am going to ask you some questions. Thank you.